Today we're working on a 2005 Acura MDX. Now to gain access to this compressor, it's underneath here. There's a shroud down there, a splash guard we have to take off, and it's very, very tight. So what I'm going to do is take this all off and then put it on the bench and show you how we're going to test this, because that way I can get the camera in there and you can actually see what's going on. Now let's review our electrical diagram first. Now you'll notice here we've got a dotted box, which means there's more to this system than we have right here. But you see down here the AC compressor clutch relay is a solid box. So the entire relay is illustrated in this diagram. If we go down here, we've got another solid box. That means the AC compressor and the clutch. The clutch is a solid box inside the other solid box. So it's telling you that the AC compressor clutch is an internal part of the AC compressor. This right down here is the ground signal. So that means when the compressor is bolted up to the block, that's where the compressor and the compressor clutch get the ground. The power is going to come from a fuse 59. It's going to go to the relay. When the relay is commanded on, this is the command side. When that electromagnet energizes, it pulls this switch closed and it then sends power. It already has ground because the ground should be there by being bolted up to the block. Now the access to that compressor for testing and video purposes was pretty tough because it's from underneath. So what I've done is taken it out here and set it up so we can see better. I've got the actual compressor that had a problem, and then I've got the new replacement compressor here. This way I can test them both and show you how to do this. Now when this compressor is actually mounted on the car, the engine and everything are up in here. It's bolted on and held on down here. So being bolted to the block, the case for the compressor gets its ground. Now I couldn't get to anything. I had to drop the compressor even to get access to all of this. But when I did, I could see that I've got a one-wire connector, and that is going over here to this plug-in, and that's going to a ground connection. So I'm going to clean this so that you can see it a little bit better. But there is our ground connection. When the case is bolted up to the block, we have a ground connection. This eyelet and the bolt then go into here, into the compressor clutch, and it comes out and we have access here. Now here's our air compressor and the compressor clutch in this solid box, and the ground comes from being bolted on. Let me simulate that. So I have a battery with a positive and negative post. I'm going to take an alligator clip and I'm going to clip onto the negative post. The other end of this wire I'm going to bring over and I'm going to clip it to the case. Now you know with the power probe you can tell which side of the battery you're on, because if I touch the positive I have a red light and it shows the voltage, and if I touch the negative I've got a green light and the ground. So with this being connected to the case, I should be able to touch this to the case of the compressor and see that we're on ground. So all I'm doing is tapping into the ground from this battery and I'm grounding the case. Now if I continue, since the case is grounded, the case, this screw goes through and is bolted to the case, so this screw should have ground. And it does. Your logic would tell you, though, that if that goes through there and goes into here, that I should have ground on this wire. So now I'm going to tap into that, and you'll notice I have no voltage. I have no green light. But actually the important thing is there's no voltage at all, so that's an open circuit. Now let me prove that to you in a different way. Now I'm going to use my multimeter, and I'm going to do a continuity test, which means I'm going to switch this all the way around. So I'm doing an ohm test, and I've got it set for my speaker. So when I touch my two probes together, you should go close to 0 volts at 0 volts, and you should hear the sound of the beep. That tells me that I have continuity. Now you know a continuity test does not tell you a circuit is good, it just tells you you do not have an open. If there's continuity, that means whatever's coming to that wire goes through that wire, or there's continuity. It doesn't tell you how good it is because we would have to load test it to find that. But it's telling us when I hear the beep that these two wires are touching. Now I'm just going to remove the ground from that compressor clutch and I'm going to put it on this compressor clutch. Now the same thing will happen here, but since I've supplied the case with ground, I can go to this bolt and you can see we're on the ground side and there's continuity. You can hear the beep. And now when I touch this connector, I'm going to put it back here. And now when I touch this wire, now you can hear the beep. And you can see that we're very close to ground. There's always some resistance in every circuit. But that tells me there is continuity in there. Now continuity basically means that the ground I'm supplying this case is going through the clutch and it's going out this wire and I have continuity there. So whatever ground is coming to this clutch is going to go through this clutch. So we've just proved and we just have our evidence that the compressor clutch lost its ground. And without a ground, the compressor clutch won't work, and that's why our air conditioning quit suddenly. Now I used this and gave the compressor clutch ground. Now to make it work, I have to give it power. Now since I have the compressor out of the car, I can't use the car, but I can just go to this point and give this wire power, which would be the same as here, and see if the clutch works. So I'm going to go to my connector. Now I'm going to use my power probe, and you know with the power probe, I can send power to the tip or I can send ground to the tip. Well, I'm supplying my case with ground, and I know that I've got ground there. So since this now has ground, I just want to send power to it, and if that's the case, if it works, you should be able to see the clutch engage. Now let's go to the bad compressor. So I'm going to take my battery ground and I'm going to ground this case. And I'm going to go to the wire here because I should have continuity. Now I can confirm that my case has ground that should travel through the clutch and then back out through this wire. So if I give this wire power, well first off you can see I have no ground there. But if I give that power, the clutch should engage. Now you can look at the multimeter here and see that I'm giving it battery voltage every time, but the clutch is not engaging. So somewhere between the case, which goes through the clutch, all the way out here, we've got an open circuit. Since we did not have continuity, whatever goes to this wire will not go through it and come out here. So by using a logical thought process, looking at our diagram, we've found evidence that that compressor clutch has lost its ground. That's why we lost our air conditioning, because the clutch would not engage, the compressor would not engage. So we're going to mount this back on the vehicle and test it all again. Now we've got our new compressor in with a new clutch, and now I'm going to command it on and off again. So now when you see the command going off and then on, you can actually see the compressor clutch engaging and you can hear it as well.